Okay, boys and girls, now we're going to look at factoring polynomial functions and then solving them. So this is basically what we did a second ago, except for we're gonna add a one step. So before we can solve it, we're going to factor it. Then, like we did on the other one, we're going to set all factors equal to 0. However, if the polynomial is not factorable and it's quadratic, then we're going to have to use the quadratic formula. And we have to recall that the square root of -1 is I. So let's just do a couple examples. In this first function, it's a quadratic, so its highest degree is 2, which means that it should have 2 roots. So when we factor this, we can ask ourselves the question, what can we multiply to get 15 and add to get 8? Because this has negative 8. Because this has a coefficient of 1, we can just use the guess and check method. So what two numbers can we multiply to get 15? I think there's only 15 and 1 and 3 and 5. So which of these two, when we add together, could give us a negative 8? Well, because this is positive, either both numbers are positive or they're both negative. In this case, they're going to be both negative, so we have x minus 3, x minus 5, that's equal to 0. And then we set both of these equal to 0 like we did a second ago in the previous video. And so we get x is equal to 3 and x is equal to 5. So that just required an extra step. So our roots are 3 and 5. Okay, we have x squared minus 64. Again, this is degree 2. We need to factor this. So this is the difference of two squares. If you recall that from the first day of this unit. So factoring this is the difference of two squares. So a is x and b is 8, because 8 times 8 is 64. So this is the difference of two squares. So this is x plus 8, x minus 8. So our solution is going to be, and that's equal to 0, x plus 8 equals 0, or x minus 8 equal to 0. So we get x is equal to negative 8, and x is equal to 8. So we have two solutions. And a lot of times the way we write that is just plus or minus 8. Okay, in this third one, once again, the degree is 2, and we're going to factor that. But we can't factor that because this is the sum of two perfect squares, so we can't factor that. So how do we solve this? Well, we have to subtract 3 from both sides, and we get x squared is equal to negative 3. To solve for x, we're going to take the square root of both sides. So we get x is equal to, and don't forget when we take the square root of something, we get plus or minus the square root of negative 3. Now, what we said before, that the square root of -1 is I. So we can rewrite this as x is equal to the square root of -1 times the square root of 3. And the square root of -1 is I, so this is going to be x is equal to 3i. And we generally write it in this fashion, plus or minus. So we still have two roots, but this time our roots are imaginary roots. So if you were to graph this on the calculator, you would see that it did not cross the x-axis because its roots are imaginary. Alrighty, let's do another one. This one is a cubic function. So we're going to, we should have about, the maximum number of roots will be 3. Let's see how many we actually have. Well, the first thing we need to do, the first question we always ask, is there a GCF? So let's go ahead and factor out the GCF of x, negative x. So we're going to factor out a negative x. And when I divide this by negative x, I get positive x squared, then minus 6x, and plus 9, because I'm dividing each of these by negative x. Okay, so we know that we have 1 0 of the negative x. We have negative x equals 0, which just is x is equal to 0. So that's going to be one of our solutions. And now we have to factor this. So again, since we have a coefficient of 1, my suggestion would be that we use guess and check. So what can I multiply to get 9 and add to get negative 6? So what are my factors of 9? I have 9 and 1 and 3 and 3. Those are the only factors. Which of these can I add to get negative 6? Well, if they both were negative, I can do negative 3. When I multiply negative times the negative, I get positive 9. So this is x minus 3, x minus 3. So my solution is x equals 0, x equals 3, and x equals 3. Now again, this has this multiplicity because I could write the factors as x times, well, negative x, times x minus 3 squared. It has that multiplicity of 2. So I'm not going to count both of those. So we say it has 2 roots. And I only need to count one of those. Those roots are going to be 0 and 3. We don't have to list the second 3. Okay? So my suggestion to you is that you pause the video and try the next 2. Okay? So welcome back. In this first one, we see that there is a GCF of x. So we're going to factor out x. So we have x times 2x plus 5x, plus 10x. That should be 2x squared plus 10x plus 5. Now, if you try to factor that, we can't find any 2 numbers that we can multiply to get 10 because we'd have to use grouping for this one. 2 numbers that we can multiply to get 10 and add to get 10. So there are no 2 numbers. So we're going to have to use the quadratic formula for this. Only on this section. Only on this section. So using the quadratic formula, we get negative 10 plus or minus the square root of 10 squared minus 4 times 2 times 5. Where am I getting these numbers from? I'll show you in a second. All divided by 2 times 2. Okay, so if we recall from here, this is the quadratic formula. And then when this is written in standard form, A is 2, B is 10, and C is 5. And so using those numbers, I'm just substituting into the quadratic formula. So we get negative 10, and that's 10 squared is 100, minus 10 minus 40, all over 4. So we don't do a lot of simplifying in this class, so we're going to just call that negative 10 plus or minus 60, the square root of 60, over 4. So that would be our answer. We're just going to leave it like that. So we do have 3 solutions. It's cubic. We have 3 solutions. The solutions are 0, negative 10 plus square root of 60 over 4, and negative 10 minus the square root of 60 over 4. So those are my 3 solutions. And then finally, for this one, we have it's quadratic. And can we factor that? I think we can. I think we can factor that. What can we multiply to get 16, add to get negative 8? That would be x minus 4 times x minus 4. So once again, we have x equals 4, but it has a multiplicity of 2, because we can write that as x minus 4 squared. So that's a multiplicity of 2, which we're going to talk about later. So then we have one solution, and that solution is simply 4. Okay? All right, that's it for solving by factoring. We're going on to the next. I'll finish your IXLs, and we will do the next video tomorrow.